Hello, everybody. Thanks for coming to the presentation tonight. We will be very happy to host tonight Joana Gomez, that is an architect in Mexico. I have discovered her work and the work of the Collab Design Office through architecture magazines. And I was really impressed by the design of the Loom Yoga Center in Tulum in Mexico, built with bamboo. And that's the reason why I decided to invite her. I mean, invite someone from Collab Design Office in our class to speak about building with bamboo. And she was really nice to accept this invitation and come to speak with us and present us her work for building this bamboo structure in Tulum in Mexico. So, Joana, if you want, you can start. You can explain us what you did, and maybe you can introduce yourself first, and then explain us your work. Thanks a lot.
Yes, hi everybody. Thank you for being here. So my name is Joana. I'm currently living in Mexico. That's where we have our office. Our office has about 10 people. I would share the screen now because I do talk a little bit about that in the presentation. Okay. So that's an outdated image. However, we are 10 in the office now. We also do design and we do building. We are not specialized in bamboo. There was the opportunity to design this building, and building it, we pushed for it for a couple of reasons that I'm going to explain later. So we just went for it. So Tulum, it's quite far away from Turkey. But just so that you have an understanding of where we are, it's the peninsula of Yucatan in the tip of Mexico. It's a place where it's tropical. It has pristine blue waters and really white sand. It used to be a former coconut plantation land. It's also home to the second world biggest reef barrier. It crosses all the way through the Caribbean Sea, through Tulum up to Holbox. And it's very close to a natural area, protected area called the Biosphere of Siancan, which is a very narrow tongue with the sea on one side and the lagoon on the other side, where the Mayans used to cross to transport food all through the Yucatan Peninsula, and also was an area that was known by pirates. It is also a place, the ground here is like a cheese. It's limestone and it's full of holes that when after the ice era, when it melted, it filled those holes. And so we have very beautiful cave-like structures underground that are filled with water, and they all connect. It's actually the biggest underground river of the world. And then on this land, the Mayan culture, their traditional structures would be some natural fiber or wood sticks walls covered with what we call palapa. It's a thatch roof. And these structures were designed to breathe. Basically, as a scheme, there were layers of structural wood, both vertical and horizontal, and they were covered with a smaller mesh on both sides to make the structural wall, and then covered with clay. And this allowed for the structures to breathe and to for the humidity to come out. So the palapa, in the way of how it's structured, it's a bit similar to that. Obviously, with contemporary materials, with contemporary shape, but it's still main structure with different layers of bamboo made in different weaved in different directions and covered with an impermeable layer that is a thatch roof, and it's made so that it breathes and it lets the air and the humidity circulate and evaporate. The yoga palapa is located on a master plan that we designed. It's basically Tulum. It's exploding development-wise for touristic purposes. And as part of this master plan, the assignment was to do 31 lots. Well, a bit more than that, but we convinced them to reduce the lots to 31. And we designed it in a way that basically there's a perimeter of road, and all the interior connection to the lots, it's only pedestrian. In the interior, we maintain the area, which is the gray big area, which is a park, which is an untouched jungle area, where we would locate the amenities, which has a spa, a small outdoor amphitheater, and as part of that, the yoga palapa, which is like this dot, like over here. So the palapa is located in the middle of this like green heart, which is untouched. It's natural jungle, which is really uncommon for touristic developments, because they usually cut the trees and then plant grass and make all these really garden-like areas. And the floor plan, it's basically a five-pointed star or flower, if you wish, which structurally is based on 5 petals, which each petal is based on 3 curved structural arches, and which come down to the ground by a footing, which is the part of steel that receives those bamboo arches, and they connect in the center by a compression ring. So that's basically it. That's the elevation. It's the diagram of the elevation is bamboo columns that basically structure these petals, and then they have a weave, interior weave that connects them all, and then cantilever out. That's a scheme of the structural layers. It's the bamboo beam of 25 by 25. So we had an issue here because the bamboo is not right in Tulum. There's no bamboo. The bamboo comes from Chiapas, and the bamboo we had to use was the most structural one. It comes from originally comes from Colombia, and but there's been planted, and there's a big plantation of it in Mexico, in the south of Mexico, which was for us the turning point of how we decided to use bamboo, because we were actually bringing it from the country and from the neighbor state. However, it's still 3 hours, actually 8 hours away. And during that process, we could not bring the bamboo in tube in order to fold and make these extreme arches. We would have to fold it while it's green. And because of the transportation and the harvesting transportation time, we would not be able to use it in its pure tubular form. Therefore, there was a decision to slice it in lattice, and then we compress it and attach it together. Basically, just if you think as how you curve the wood to make a chair, you basically slice it in layers, and then you compress it together, and you are able to bend it with heat. That's exactly the same technique we use. So this diagram explains how the petals are formed. It's the structural columns with the interior layer of bamboo that expresses the geometry of the petals. 3 intermediary layers that are a tight weave in different directions that gives the structural stability. And the exterior of the thatch roof is just to protect from the rain. These petals are attached to the ground through a kind of steel shoe that receives, basically receives those columns and connects to an underground footing. And then for us, one of the complicated or more complex things in the project was indeed to define these angles, the precise angles, because it's angled in 3 directions of these footings in order for this to allow the precision of the arches to come completely symmetrical and all in the same direction. This is a quick explanation of the different layers of the footings. That was what we were able to do so that on site both the steelsmen could understand to produce it, but also the people that were going to install it on site could install it. And this is a detail of the compression ring on top, which is also works the same way, and it's the only 2 parts of that are not bamboo of the project. So as a zoom out of each petal, we wanted to show the geometry or to stress aesthetically the geometry of these petals. And therefore, we came up with a grid that we studied in the office, and we studied different configurations and different sizes until we were happy with. And then we brought it back to Grasshopper to be able to control the deformation. There was another challenge we had in this project, is that we wanted this grid to express the geometry when it tights and when it expands, but we didn't want it to deform it, which would be what it happens naturally when you build it directly on place. So we use Grasshopper to be able to control this geometry and grasp exactly the connection points between all these 3 different three different directions of these bamboo slices in different depths, so that we would get that idea of the grid, the interior grid. And also we were able to communicate on site, because this whole structure was built by artisans. It's like weaving a huge basket, and it's very difficult to control on site exactly how everything ties up, because the structure is very complex. So that's some photos of the construction. You can see the compression ring in steel, the footings in steel, and all the structure beams are bamboo slices that are strapped together. And then we just basically started weaving continuously the 5 petals so that they tie together, also because they cantilever out quite a bit. So, and the way we did that is that we formed those arches on the floor, and then we lift them up, and you can see that they are supported by extra structure to hold them in place while we were weaving, connecting them together like a big basket, so that in the end, when you take the structure, like the additional structure, they hold in place. It's just like when you build cantilevers in concrete. That's the different layers of the interior geometry. That's a zoom in photo of the connection point of the steel shoe receiving the bamboo beams. These beams, so the structure was done by a structural engineer specialized in bamboo, and we don't really have hurricanes here. Sorry, we don't have earthquakes here. We have hurricanes. So one of the biggest concerns was the shearing winds. It's what we need to worry here. However, we need to structure, our structures here need to at least be proof for earthquake of grade 1. We had one very recently, was the very first earthquake ever here. So that's why we had to had 3 structural layers of a very tight weave in different directions. That's what this is. It's exactly like weaving a big basket, and they go in different directions, overlap, so that they tie all those petals together. It's a review of the mesh. And that's the interior result. So it has a more visible layer that expresses the geometry of the building. And then it has 3 layers behind of a very tight weave that makes the structural connection and strength between them. And then on the outside, it has the zacate for the thatch roof to protect from rain. Some interior photos. This was the very first build project in that development, and we wanted it to have a statement of sustainability for the area, because, as I mentioned, it's being developed quite drastically for tourist purposes, and we also wanted it to be like a center point of reunion for people in that development when it's finished. So it's an open structure that it's common here for developments to have a reunion palapa, so we call it, where friends meet, where you can do yoga, where you can do meditation or workout sessions, or have small conferences, small gatherings. It's very common here. That's the compression ring that ties on top all these cantilevered structures out. We added uplight to stress the geometry even more and enhance the geometrical pattern of the interior. And that's basically it. I don't know if you guys have questions.
Okay, thanks a lot, Joana. It was really nice presentation and really interesting to see this building. I mean, I was impressed by the picture without knowing exactly how it was built. But now that I can see it how it is, it's very, very nice and interesting work, especially working with a different technique than we have studied in class. We have studied using bamboo poles for construction, but using now bamboo slices to recreate beams and all this structure was really interesting to see. So,
yeah, we as I said, it would be very difficult because it's a very complex technique to bend bamboo. It needs to be green, and you need to fill it with hot sand, and that's how you can bend it. It would be just logistically very difficult for us. So my partner he was a boat builder at the time, and in the same way that you curve the wood for the boats, you have to slice it in thin slices, and then you can create a mold on the floor, and with heat you can bend it, and then you do different layers and you strap it together, so when they dry they actually hold the shape. And that's the same technique that is used for this structure. It was logistically much simpler than using the full tube, And also the builders that worked with us on this project, they had that technique of using the wood lattice. So it's just more efficient. You waste less material. And for the kind of cantilevers that we have, it offers much better structural resistance. Because you basically are making a solid column of 25 by 25 with slices compressed together. So it's very strong.
And my question was about these columns. How all the slices are held together? Only by this metal string that we saw around, or is there any glue or
no,
anything like
they actually, the builders do, they screw them together as well. And they peel parts of the bamboo and they screw with bamboo, just like you do with wood, which the same wood, I'm not exactly sure how you call that in English.
Okay.
Yeah, exactly.
Okay.
It's the same technique. It has both. It has bamboo like nails, and it also has nails itself.
Okay.
And the straps.
And the straps. Okay, so this I understand. And I had another question also that was really interesting. How the touch is attached on the structure? This
The what?
The touch, the cover.
We put spacers, wood spacers, because the issue with the bamboo can be very resistant if it's not exposed to water and humidity. And also because of the humidity to get trapped, because the thatch roof always lets some humidity, it traps humidity, right? So we had to leave a spacing of 10 centimeters between the bamboo walls and the thatch roof. So it's basically a spacer of 10 centimeters. And then on top of that goes the normal structure that attaches the thatch roof, which is wood bars, and then the thatch roof. Yes.
Okay.
And that little spacing allows for ventilation so that it doesn't rot both the bamboo and the thatch roof.
Okay. And what material did you use for the thatch?
It's just what we call here zacate. It's grass. It's just grass.
Okay.
Yeah. Here there's two types of palapa, of thatch roof. It's the guano, which is a tree. It's literally the leaf of the palm tree, and grass. And guano was protected for a long time because this stopped having guano. So sometimes you can only use guano, sometimes you can only use grass. Right now, guano is actually, it's very rare to build a palapa with the traditional guano, so you just use the grass.
Okay. Thanks for it. And does anyone else has question for Joana here?
Can you hear me?
Meli. Yes, Meli, we can hear you.
I have a question about the bamboo, the way you use it. You said that when the bamboo comes, you divide into fibers and compress it together, to make that material. My question is that while you do that, is it 100% efficient, or in the process did you lose a couple of bamboos by doing that?
You mean by doing the lattice?
Yes, I mean, like, let's say while you're doing, did you lose some of the materials, or is it 100% efficiency? Like,
well, you need to prepare very well with the sizes of the bamboo and the width. There's a certain width of the lattice that you need to cut it by, so that it's structural. So that it has the structural efficiency. So yes, there's always a waste of material that you can use for other things. It's not that it goes to rubbish, but you can use to do furniture and do other things. However, for this project, we would not have been able to build it just with the bamboo roll because of the distance that we are from the source. I mean, they need to be brought by truck. It's an 8-10 hour of transportation, plus they need several days of harvesting, because the bamboos need to be really mature, and there was really a lot of bamboo. On the other hand, it's structurally stronger to do it this way for those columns to have the compressed lattice like that. So that was a decision that was taken both by the structural and the builders. They advised us on use that as lattice, and therefore we designed the building with the lattice instead of the rolled material. So yes, there's always a material waste, but on the other hand, gives you much more flexibility on the different sizes of bamboo or how mature you can use or not, because it would limit, if you would use the bamboo in its raw form, in this natural form, that would be very limiting for the kind of bamboo or how old you would have to use them, as they would have to be of a certain size and have a certain bamboo wall thickness. You know, the structural ability that is given to the bamboo, it's because of the wall thickness between the outdoor tube and the inside hollow. That thickness determines the structural efficiency of the bamboo. For that, the bamboo needs to be of a certain age in order to achieve that certain thickness. So it would limit us tremendously on just the pieces of bamboo that we could use. So this we were able to use less mature bamboos and have the same structural efficiency.
Thanks a lot, Joana. Does it answer your question, really?
Yes, actually, I have a second question, if it's okay.
Yeah.
It's about the hurricane you mentioned. I mean, I know about earthquake, but I don't have much information about hurricane. And for earthquake, it's about your fundamentals. It's about how you build your building's fundamentals. But for hurricane, is it an advantage to have a flexible building, a flexible material like bamboo or steel, or is it depending on something else?
Yeah, it depends. Basically, you want to calculate your building for the shearing forces, for the torsion. So for earthquake, you need to plan. Basically, you want to have your building being somewhat flexible, because when the ground moves, you want the top to be able to move softly with it. So for instance, I lived in Mexico City many times, and the structures that are earthquake proof, what they do is that they use springs and they detach the foundations to the top so that the shock absorbers actually absorb that movement and transmit it very softly to the top. With hurricanes, it's slightly different though. You need to calculate your building for torsion. And the wind can come in any direction in a hurricane, and it can spin one way and then suddenly start spinning the other way. So for this, that's why it's better that the structure is all tied up and works together. I mean, the structural engineer for this project, when we were questioning about it, he joked that it's probably easier that if anything happens, that the palapa detached from the floor and flies like a ovni rather than it comes apart, because of the structural layers of the weaves that they have that bind it together. It would be very difficult that comes apart.
Okay.
Okay, thank you.
Thanks a lot.
Hello. I have a question. Thank you for your wonderful presentation, Joana, and thank you for arranging this, Matthew. And so I really wonder about the bamboo weaving system, especially, and I just want to add this, I hope in this world, this kind of buildings will be more, and this is really wonderful. And as you mentioned, because of the structure, so it can just fly by itself. So it's really a natural structure, I think. And I really wonder about the bamboo weaving, like all the layers you put on all of it. I think the layers are not like weaving in a basket, as you mentioned. So
yeah,
I
they are.
wonder why you choose like so it's really gain structural efficiency also when doing weaving system. I really wonder why the structural engineers choose this way. And
we chose it.
Okay, and the second question is like, so how old were the bamboos that you choose for the efficiency? Thank you.
Okay, so give me a second. I'm gonna get something that's gonna help to explain. Give me a second.
That's it.
So basically, when you, well, first of all, the builders, they were a bit more traditional. They were used to build a bit more traditional, and the way that they were proposing, it's kind of this bird's nest that goes. If you think about the bird's nest, it has no logic. It has no order. Let's say no, it has a logic. It just doesn't have an order. It's basically you weave in whatever direction to make it structurally strong. For aesthetic reasons, we wanted the first layer to be a grid that stressed and expressed the geometry that we were creating. And then the layers above, they are literally weaves like this. Like when you're weaving a basket, yeah, like this. And then it's one layer in one direction. Like if this is horizontal, then you will have on top one that is like this, vertical, and then on the bottom is another that is horizontal. I mean, I have to admit that even though the structural engineer, in fact, the Palapa only has 2 layers. However, the structural engineer, he advised 3 layers. We on site saw that it was really strong. I mean, that thing was not going to go anywhere. So for efficiency, for costs and everything, there was a decision on site to only make it 2 layers. But it's literally this. It's a basket. It's like really weaving a basket on one direction, and then on top you weave it this direction. And the one thing is that you weave all the layers continuous, like all the 5 petals, because that is what ties it together and allows them, because they are cantilevered. They are basically like that, only connected on the bottom and then on the center. So it's like when you're giving hands and you're like balancing to the front. If one of the hands fails, you fall, right? So that's why they are tied continuously together. So that creates this, it's basically a one structure. Even though they are like 5 petals, it's a one continuous structure.
Yeah, well, I just from the photo, as I see, like the first layer is horizontal and the second layer is vertical and the third layer is horizontal, right? Or
yeah,
totally
here,
like in the basket.
I'm gonna share the screen again. Wait a second. I'm gonna go back to that picture.
Because it's the structural efficiency which really functions the material.
So this first, oh, sorry. So I think it's easier to see in this aerial photo. Yeah, this one. So you see how there's one that is in the direction of the petals, and then on top we're weaving one that is like on the other direction, and that is what allows it to. And all of them are tied continuously. So they were tied, like as the bamboo obviously has a length and they need to be attached, but they were like done like this. No, there's not like a line and then it follows, you know?
So with this weaving system, the structure behaves whole, right?
Yes, exactly.
Okay. And thank you so much. And how old were the bamboos?
Between 6 and 8 years, yes, around 6.
Okay. Thank you so much.
You're no problem.
So do we have any other question? Anyone wants to have more information about the design or how this this palapa was built? Yeah, this is a really interesting. This was what I was wondering too. Can you just on the previous picture, Joanna?
Yeah.
Or on this one, on the previous picture. I mean,
this one, this one,
yeah.
This one.
Yeah, this one. I don't know. It's not changing on my screen. But anyway, this one is fine. So the structure we see. I mean, this that is forming some kind of. Yes, this one. All these lozenges that has formed, they are not holding the structure. They are just to underline the structure.
This one is the bottom. So we started from the geometry we see.
Yeah. Yeah.
And then on top of that, we start building the structural layers.
Okay, that's what I understood. So this is just for showing the geometry and as a support of the structural layer.
Yes, yes and not. I mean, it does help because this is like it goes in 3 directions,
yes.
And it helps tying this these arches together. Yes, but it's not as structural as the other ones. Yes.
Okay. Okay. Thanks a lot. Is there any other question from the students, from anyone?
If it's not, I have one more question. Actually, when I said that, it came up to my mind. It's about the construction. When you started to build this, where did you start? Did you like made? How can I say? I mean, there's 5 pieces. I just curious about? Did you make each pieces in a different place and connect them each other again in a part, or did you start from the columns and continue from there?
Let me see if I can quickly find some previous pictures. I could find it on my phone and try to show you in the camera. Sorry. We started basically building these arches, forming. We put like estacas. I'm not sure how to call it in English, but basically we draw the shape in the floor of the arch, like we trace it on the floor, and we started making those arches, and we bend it, and then we lifted the arch with those puntales, like with this additional structure you actually see here. Can you see my screen?
Screen by your camera or this presentation?
No, the presentation.
Yes, I can see.
Okay, so you see that, you see my mouse, no? Here,
yes,
there's, yeah, this is structure that is basically holding this arch, because it's not yet, this arch is not yet connected to this one structurally, or it's not structurally strength connected. So we started by building this beam, and then this beam, and then that beam, and we lifted, and then the next one, and then the next one. So we built all the exterior beams. In the end, it's what comes back to plan. It's this. That's what you build first. These lines are those columns, like those structural columns. And then you start filling them in the middle to come back to this.
From looking the plan, did you add the ring later or after the putting every canceller together?
Sorry?
I'm just judging from the plan. Did you add the middle ring that you showed that?
Yeah, when they are, yes, when they were all up, we put the compression ring. Yes.
Okay.
Yes, I can try to find
a question also.
Yes.
Oh, sorry.
Yes, it's good. I'm trying to find a little bit. Yeah, I don't really have, well, here I do have, I don't know if you guys can see it.
It's so shiny. Wait.
Can you, is it visible or is not visible
No, it's
at
not.
all?
I can't understand.
It's not, okay.
It's not visible. Thanks for trying. Yeah, Selim, you had a question?
Yeah, actually, my question is a little bit different about connection points, like connection detail, because this year, actually, I made the project in summer. I designed a bat, and I did also. I used the material look like bamboo, but just I used actually rope and tie for connect them, like connect the pieces. But when we design a building or like the things which you did, if we just tie it, can it be enough?
It can. I mean, for this particularly not, because those cantilevers go really far out. We analyzed it and we wanted to use rope. The builders and the structural engineer, well, it's also because of the conditions here, because it's very humid and it's very salty. The air is very salty. So everything rots very fast. Even though just near here in Valladolid was some of the biggest producers of anacan, which was shipped to the entire world for when the explorations like back in the 16th, 17th century were for navigation. We found that it was not going to be strong enough to hold this cantilever, these petals cantilevered out, because you basically need to connect. It's too many connections to use with the rope. So in less complex, to answer your question, yes, you can do. Actually, Asian structures do that a lot. You need to do it in less complex structures, though. For this structure, that was not possible.
Yeah, thank you so much, because I thought that, like, okay, if I want to design something ecological, I think that can I use everything which can be like ecological material also, like some time, some like tide is also like ecological things which is made from like leaves. That's why I asked it.
Yes,
Thank you
yes,
so much.
you can. I mean, it all comes down to if you want to be sustainable. People have this idea of sustainability only by using what is organic materials and stuff. It's part true, but it's part not. Because if it all comes down to what you have locally in your area. For us, we always were very curious about bamboo. We never used bamboo before, because for us, having to bring it from Colombia or from Asia, it stops being ecological. And yes, we did analyze a lot of different fibers that we could do for instead of the nails. However, because of how they have to be tied together with the kind of material that we needed to tie it, we would have to bring it from the States, and it's just not sustainable from the point of view of economics, because in the end, we have a client and we have a budget. And therefore, for us was a mix of solutions that made it suitable to the place where it's built. That was basically what it was.
Thank you so much. It's wonderful presentations also. Congratulations.
Thank you. Thank you.
And thanks a lot also for this explanation about sustainability of the building, that is not only natural material, but also local and what is available. It's very important to precise, because it's totally true.
Yeah, there's actually something that I would like to add too. I mean, for us, particularly, and what we do in design, as I said in the beginning, we don't really specialize in bamboo. We try to research a lot of things. We actually do build more with concrete, because of most of the other projects is it's what it requires. But yeah, this discussion of sustainability is very interesting, because if a building is done of all natural, and it lasts 5 years, or a building that is in concrete and lasts 200 years, I'm not sure exactly which is more sustainable, right? I think the issue now is that we basically don't have buildings that last 200 years, because after 30 years we are bored with them and we turn them down or tear them down, and then we don't know what to do with the waste. Another thing that is, I think it's important to address in sustainability, and I don't know that that many programs stress that, it's the social and the social sustainability and the community, because a lot of the solutions, Tulum is a very interesting place because nothing lasts here. Basically, technology that you bring, if you want to try to bring solar panels, if they need batteries, the batteries after 2 years they are dead, and then you end up with all the lithium and all this waste that you don't know where to put or what to do with it, because the air is so salty and it's so humid, it ends up corroding everything. So you basically, if you want to use metals here, you need to use stainless steel or inox or something that is basically not anti-corrosion. And that is really interesting, because when people address, I mean, we do use solar panels in our buildings, for instance. We don't use batteries though. We use them connected to the grid so that they can give energy directly to the grid. And then you're using that energy that is provided by the city grid. So you basically use it as to provide energy to the grid that then you use, but you avoid the batteries. But my point was more that I see that a lot of sustainable solutions are very based on technology and very based on computerized and machine-made products. And there's an interesting component of that, which is I think we should use computer and we should use machinery, but we should not forget that they are on the service of us. On another project that we made here, it's called Tulum Tree House. It's also very it was also very published. We tried to address that by using furniture that is only Mexican made and is local made. We made it directly with artisans. And this is very important because these communities, they need this labor in order for them to sustain their community, for the communities to self-sustain. Like the economic sustainability is very important, and is also a very big factor of the sustainability that is not very many times addressed. So sustainability does not really pass only by materials or techniques, but also on how we support each other as community, and we all can thrive as community and can all elevate together as a society. That's also an important part of sustainability that is not very or is not addressed many times. And that's basically it. So this project I particularly like because, yes, we use very advanced computer programs to be able to determine all that. But then this is all handmade. It was all built by hands, you know, and that's really cool because it employed 30 people working in this palapa for a couple of months that were there, and they learned their skills and they improved their skills. And I think that's very interesting.
Thanks a lot for it. And yes, that's very interesting to teach also people some skills they could use for the following time and employing local people instead of bringing everything from abroad or from another region in some cases. So yes, thanks a lot for it. So
you're very welcome.
Is there any other question? No? So if there is no more question, I can only thank you a lot again, Joana, for all this beautiful presentation and especially for your beautiful work. I was really happy to have you and explaining this project to students. So, and I wish you good luck for new coming projects in the future, and maybe we can speak again for presenting some other project in the future in this class to students interested with so many sustainable, beautiful projects.
Thank you so much. Thank you, guys.